So in this video we are going to see about the enhancement type of MOSFET, and at last we are going to compare the performance of JFET and MOSFET together. So here in the enhancement MOSFET, here the symbol diagrams for the N type and the P type of the enhancement mode MOSFET is shown, and this is the construction view. So the basic difference between the previous video, which is done for the depletion mode MOSFET, and this enhancement mode MOSFET, is that there is no physical channel present between the source and the drain terminal. So whereas in the depletion mode we will have a physical channel present. So here the construction view of the N channel E MOSFET is shown. So here this is the P-type substrate, which is the base, and over which we will have two N-type impurities diffused, or it is doped on both the sides. So one is going to act as a source terminal and the other is going to act as a drain terminal. So over which we will have an insulating material, which is the silicon dioxide, and then we have ohmic contacts, which is for making the physical connection of the three terminals, source, gate and the drain. So they are metallic contacts or ohmic contacts. So this is going to be the substrate, and here it is shown there is no channel physically present between the source and the drain terminal. So when does the channel will get formed? So only when there is an voltage applied, the channel will get formed and there will be a flow of current. So this is the construction explanation, and in the operation we are going to show the MOSFET operates only in enhancement mode, this MOSFET. So when there is a large positive gate voltage applied, that is a positive voltage applied at the gate terminal, and when the you apply the positive voltage at the gate terminal, and the drain will be applied positive with respect to the source. So at this time we have a very small reverse saturation current flowing, because the FET is said to be under reverse bias. So this, under this condition, we are going to keep the gate and source voltage as 0. So in this case the MOSFET is going to be in off state, that is, it is not switched on, it is going to be switched off condition when VGS is equal to 0 and there is a positive gate voltage, a positive drain voltage is applied. So now when the gate is made positive, now the positive voltage is going to be applied at the gate terminal with respect to the source and the substrate. So then the negative charge carriers, which is within the substrate, they will be attracted towards the gate terminal and they will accumulate near the surface of the substrate. So the gate voltage is increased and we will have more and more electrons getting accumulated under the gate, and this is going to form an inversion layer, and there will be a drain current which will be started to flow. So this is the operation which is explained, and at a particular value of VGS, there will be a measurable drain current between the drain and the source. So the strength of the drain current is going to depend upon the channel resistance, and it is also going to depend upon the number of charge carriers that is attracted to the positive gate. So this gate voltage, applied gate voltage, and the current value which is built is actually shown here. So when the VGS is less than the threshold voltage, which means the drain saturation current will be equal to 0. So this is the case under VGS is positive, and when VGS happens to be greater than the threshold voltage, the drain current is controlled by the gate voltage, which means when you increase it, it keeps increasing. When you decrease it, it will also get decreased. So this is the characteristics curve which is plotted with respect to the drain voltage versus the drain current with respect to the constant values of the various VGS voltages. So, and then this is the transfer characteristics curve. So the transfer characteristics curve will be plotted with respect to the gate and source voltage versus the drain current. And when VGS value is very small, um, then when it is less than or equal to 0, the drain saturation current will also become very small, and when VGS is made positive, the drain current increases. So this is what is we saw in the characteristics curve also, and it has been explained in terms of an equation where the drain current is equal to K into VGS minus VT the whole square. So from this you can get the value of K. So this is the equation for the transfer characteristics of the MOSFET. And the transfer characteristics, again, it is shown for an N channel which requires a positive gate voltage. So here it is shown on the N channel as well as for the P channel of the VGS versus the drain current. Then this is just a summarizing of what we saw in this video. So here we saw about the construction of the enhancement mode MOSFET, and we also saw the transfer characteristics of how the gate voltage increases with respect to the drain current, or when you increase the gate voltage, how the drain current increases, vice versa. So this is the drain characteristics, where only the drain voltage versus the drain current is plotted with respect to the various values of gate voltages. And then this is the summary table of the comparison between the junction field effect transistor, D MOSFET and E MOSFET. So to generalize it, here we have given the symbol diagram of how it varies between the MOSFET and the JFET. And here also we have the drain current with respect to the drain saturation current uh, equation with respect to the pinch off voltage. So it varies only for the E type of MOSFET, whereas it remains same for JFET as well as D MOSFET. And this is actually the transfer characteristics which is plotted for the JFET, D MOSFET and the E MOSFET. So here also there is not a big change with respect to JFET and D MOSFET, because in JFET as well as D MOSFET we have physical existence of a channel. Only in E MOSFET we don't have a channel which is physically present. So that is the comparison between the JFET and MOSFET. And also JFET is operated only in depletion mode and not in enhancement mode, whereas MOSFETs will have two modes of operations. And also MOSFETs have high input impedance which is greater compared to that of the JFET. So JFET characteristic curve is also more flat. So the operation of the reverse, the JFET is operated under reverse bias on the junction, so at that time the gate current is larger compared to the MOSFET. So also the manufacturing construction difference we saw earlier. So that's all about the comparison between JFET and MOSFET. Thank you.